increases due to steric hindrance. Now the question, nucleophilicity of R3C minus, R2N minus, RO minus, F minus is in the order. You see, R3C minus, carbon, nitrogen, oxygen, fluorine. We are moving along the period. First comes carbon. As we move along the period, nucleophilicity decreases. So the answer is first is greater than, second is greater than, third is greater than fourth. So the answer will be first. Which of the following is an electrophile? Electrophile is electron deficient. So any species which is electron deficient will be an electrophile. Hence, if we see the choices BF3, Cl+, Ag+, SO3, out of these BF3 has got 6 electrons, so it is electron deficient. Cl+ also has got 6 electrons, again it is electron deficient. Ag+, although it is not electron deficient, but it has vacant d orbitals. So in this vacant d orbital it can accept the electron, hence behave as a electrophile. SO3, although it is not electron deficient, again sulfur has vacant d orbitals, so it can also accept the lone pair of electron, hence this is also a electrophile. So all the four are electrophiles, hence the answer is fourth. In CH3CN and HCHO, the electrophilic sites are, electrophilic site will be one which is electron deficient. We know nitrogen is more electronegative than carbon, so it will pull the pi electron towards itself, making carbon electron deficient. In the same way, HCHO, oxygen is more electronegative than carbon, it will pull the electron towards itself, making carbon electron deficient. Hence, in both the cases, the electrophilic sites are carbon. So the answer is second. In the reaction, ethene plus bromine gives this, then CH2Br CH2 cation plus Br minus gives this. The electrophiles are, you see, although bromine molecule has complete octet, but dear students, bromine always have a tendency to gain an electron. So bromine will pull the electron of alkene towards itself. As a result, bromine will be electron loving species. So in the first case, Br2 will be the electrophile. Both the bromine atom will behave as electrophiles. Now after that, in the second step, the third, carbon, is electron deficient. It is a carbocation. Naturally it has got 6 electrons. So it will accept the electron pair from Br minus. Hence out of third and fourth, third is the electrophile. Out of first and second, second is the electrophile. So the answer will be second and third. Hence the correct answer is fourth. Stability of carbene depends on the extent of overlapping. Greater the extent of overlapping, greater the stability. Now which of the following singlet carbene is the most stable? All are halides, CF2, CCl2, CBr2, Ci2. If we compare the electronegativity, then it seems as if Ci2 is the most stable. But actually it is CF2 which is most stable. Why? Because carbon has a lone pair of electron. It has also a vacant p orbital since it is singlet. It will overlap with the p orbital of fluorine which has a lone pair of electrons. So p pi bond will be strongest in CF2 as compared to CCl2, CBr2 or Ci2. CF2, in CF2 carbon is, the vacant orbital is 2p, fluorine the lone pair of electron is in the 2p, in CCl2 vacant orbital is 2p but the lone pair of electron is in 3p. In the same way in bromine it is in 4p, in iodine it is in 5p. For overlapping they must be of the same principal quantum number. Hence the best overlapping is in CF2, so CF2 is the most stable carbene, hence the answer is first. Which of the following is paramagnetic and linear? A paramagnetic species must have an unpaired electron, and for a molecule to be linear, the hybridization should be sp2. Now CH3 radical, although carbon is sp2 hybridized, but for the molecule to be linear, it should be sp hybridized. CH3, the carbon is sp3 hybridized. So although it is paramagnetic, but it is not linear, it is triangular planar. Singlet carbene, both the electrons are in the same orbital. So carbon is sp2 hybridized. Hence it is angular due to the presence of a lone pair of electrons. So it is angular as well as diamagnetic. So this cannot be the answer. Now out of triplet and CH3 plus, triplet carbene, carbon with 2 unpaired electrons, and unpaired electron occupies p orbital, means both the p orbital are not taking part in hybridization. So one s and one p orbital hybridize. hybridization becomes sp, shape becomes linear. Now it has two unpaired electrons, and one which has unpaired electron will be paramagnetic. So the answer will be triplet carbene. CH3 plus carbon is sp2, it is diamagnetic as well as triangular planar. Now in Riemann-Thieme reaction, which of the following is the attacking species? Riemann-Thieme reaction undergoes electrophilic substitution reaction. In the case of electrophilic substitution reaction, electrophile attacks, and we know electrophile is one which is electron deficient. It has a vacant orbital. So out of the singlet triplet CHCl2 CCl3, singlet carbene has got one vacant p orbital and a lone pair of electron. So due to the presence of the vacant p orbital, it can accept the lone pair of electron of benzene ring. Hence it behaves as an electrophile. Triplet carbene cannot be, because both the orbitals has got unpaired electrons. So it is a radical and not a nucleophile and not an electrophile. Out of CHCl2, CCl3, both are free radicals. Hence the correct answer is singlet carbene.